Hi guys, so today we are going to solve permutations words second problem. Okay, so before starting, let me tell you that this problem is exactly similar to its previous one, that is permutation words first. So why we are doing this problem again and again? Because these are the easier one problem. These problems are very easy, but in further recursion, when you will go deep into recursion, you will find that some problems can easily be solved using method 1 problem, method 1, which is solved in words first problem. So in words first problem, I solved that problem using method first. What are method first and what is method second? I will explain you. And now in this problem, I am going to use method second. Understood? So these questions are easy. If you will copy the method first code and copy it here, it will work. It will work with some modifications. But the main fact is that you should know both the methods. That in any question, if you got stuck, then you should know now that yeah, I am not getting this method, but I know this method. So I will do this question using this method. Understood? So that's the main motive to teach you that both the methods can be used to solve any permutation and combination problem. Understood? So this is the main motive, that both of the problems are exactly same, but we are going to solve them using different methods, and both of the methods are very amazing. Firstly, I will discuss some bit about method first. After that, we will completely solve this question using method 2. Okay. So what is method 2? Method 1. You know that? Do you know that? Because if you have not watched that video, words first, then just watch that video, because the main motive is to teach method first and method 2 both. So if you are directly coming to this video, then that doesn't make sense, because you should know both the methods. Because this problem is easy. Yeah, I know that you can solve this problem, but further recursion problems, which are of hard category, cannot be solved if you know only one method. Because if you know both the methods, you can use them interconvertibly. Okay, so let's discuss about first problem. Basically, if you are having 4 boxes, let's say you are having 4 boxes and you are having 4 balls, 1, 2, 3 and 4. Okay, you are having 4 boxes and 4 balls. So in method 1, what we are doing, basically this is the statement: every box is choosing which ball to hold, Okay, so this is the case, that every box will choose that I want to hold this ball, and this ball. So basically, what's the graph? Basically, I am going to write only 1 or 2 calls, and I am talking about this box. So this box is having 4 choices. Either it can hold first ball, so 1 dash dash dash. If it is deciding that it want to hold second ball, so sec 2 dash dash dash, 3 dash dash dash, and 4 dash dash. So this is the case. Every box is going to decide that which ball to hold. So we are going to traverse over balls. In this case, we are traversing over ball. Okay, but our case is totally different, because in word second or in method second, we are going to traverse over boxes. So can you imagine the statement? Every ball is going to decide in which box to be placed. Okay, so every ball is going to decide that I want to sit here. Okay, so what the graph would look like? Graph is I'm talking about first ball. So first ball will decide that I will sit in the first box. So 1 dash dash dash, easy. If it decides to sit in the second box, dash 1 dash dash, third box dash dash 1 dash, fourth box dash 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 1. So this is the difference. Things are exactly same. Our answer will be exactly same, but here you can see box is deciding that I will choose the balls. Here ball is deciding that I will choose the box. Okay, this is the basic difference. Now I am not going to discuss the whole method 1. I have given just quick insight. Now we are moving to method second. Okay, so what I did in the first insight of this video, in this question, basically when I saw this question, now what I did, basically we are having current character. That means you can simply take what are the parameters: cc, str, spots, cc, str, spots, and the last occurrence, LO. Let's change this name, LO. Okay. So what these are representing, just take this example. This is the generic example. This can be applicable to most of the cases. 4 boxes and 4 balls. Very easy. Now, CC represents, basically before CC, STR represents the set of all the balls. This represents set of all the balls. That is 1, 2, 3 and 4. Okay. This is the set of all the balls. CC represents that I am talking about which index ball. CC represents I am talking about which index ball. That is, let's say this is 0. So I am talking about 0th index, that is first ball. If this is 1, that means I am talking about second ball. Understood? So this is the case. So I hope you guys understood what is CC, what is STR. Spots represent the boxes. Spots represent the boxes that after, when we hit the base condition, now I am going to print our spots, because spots hold that in this box, this ball is present, in this box, this ball is present, and that's what we need to print. So you can take spots as boxes. Now what this is least occurrence, why we are using this, I was not able to understand this at the first sight. So what I did in the first go, I will explain that. After that, what I understood, I will explain it. Okay, so I didn't use this. I was not getting any point why we are using this. So I directly get upon the question and write the code. So what's the code? Basically, every ball, let's say initially CC is 0. I'm talking about 0th index ball. So what I will do, I will get the 0th index ball. I will get that ball. So character CH equals to STR of CC. So I got the 0th index ball. Now what I have to do, what are the choices? I will check whether, I will check on all the boxes and I will check which box is empty. If that box is empty, I will put myself in that box. Let me explain again. Basically, I am holding this ball. So I am holding 1. Now, what are the choices? 1 can be set into first box, second, third and fourth. So I have to traverse over spots. And what will happen? If that index, if that box is empty, I will put myself and call the further recursion call. So let's write this. Basically, we are going to write it line by line. Okay, line by line. So character CH equals to STR of CC. I'm getting that index ball. Now I have to traverse over the spots, the boxes. So I is less than spots dot size. That's okay. I plus plus. Now I'm traversing over the boxes. If that box is empty, that means if spots of I equals to null, that means that box is empty. So in this case, I will put myself into that box. So spots of I equals to CH. Very good. I put it myself into the box. Now, let's say I'm talking about 1. Okay, so these are the 4 empty boxes. Now I put 1 here. So 1 dash dash dash. Okay. Now in that case, what are the next further calls? I will increase the value of CC. I will increase the value that 1 is placed. Now it's turned for second. So 2 will be placed in the further boxes. So what I will do, basically, I will call the recursion call generate words. Okay, CC will get increased, STR will be remain same, spots will be passed, and LO. I am not touching LO. LO means last occurrence. And after getting back to backtracking, I will place null there. Okay, to empty that place, to make that place empty. After that, when I will hit my base condition, when I will traverse all of my balls, when CC becomes 3, that means not 3, 4. When CC, this is 0, this is 1, this is 2, this is 3. When CC becomes 4, that means I have put all of the balls into boxes. So in that case, CC equals to str dot length, or length. So in that case, what I have to do, I have to traverse over my boxes. So 4 int I equals to 0, I is less than spots dot size. Okay, I am traversing over my hash vector, and then what I will do, I will print the value present into that box. So cout spots of I, and after printing, just change the line and end. Very easy. So this is the exactly same code which I have written in the first go. So if you found what's the mistake, what is the difference between the output which you are going to see, so that's good, very good. because you are better than me. Okay, in that case you are better than me. So let's run this. Okay, we are getting our answer. So let's get this answer into our open board. Okay, Control C and Control V. Oh, so you will see that we are getting some output. Yeah. So what this output is representing, basically there is the mathematics behind this output. Mathematics. So what's that? I'm going to see. Yeah. Now, let's say. So you can see that the desired output. What's the desired output? Okay, I'm talking about AABB. AABB. So you know the permutation formula. You know the permutation formula. Basically, we are having 4 spaces and 4 number of boxes. Oh no, 4 boxes and 4 balls. So 4P4. This is our formula. So 4 factorial upon 4 minus 4 factorial, 0 factorial, that is 1. So 4 into 3 into 2, 24. So you can see these are 24 number of outputs. I can say these are 24. Okay, that's good. But why this is showing us wrong answer? Because you can see every string is repeated 4 number of times. Every string is repeated 4 number of times. Why? There is the very good mathematical proof, because A is repeating 2 number of times. So 2. B is also repeating 2 number of times into 2. This is the reason. Why? Let me explain again. Basically, in tree, I will explain you using tree. Okay, let's move to tree. This is a little bit complex. Basically, we are having string A and B. A small string. So we are having A, B, and we are having 3 boxes. So dash, dash, dash. Or instead of dash, 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 what I can write? I picked up this ball. A. I picked up A. So initially, all the boxes are empty. Now when I picked up A, what are the choices? A can sit into first box, second box, and third box. So A dash 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 A dash 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 A. These are the choices. A ball will decide that in which box to be sit. After that, I'm talking about this A, this second A. Okay, so this second A can be sit into first box or not second box, then third box. Okay, here A dash dash A dash, here dash A and dash A. Okay, these are the choices. After that, I am talking about B. So B can be sit here AAB, ABA, AAB. Okay, why these? There are 2 remaining box. Okay. So I forgot that. Yeah, A will be here. Sorry for that. But AB, BAA, ABA, and BAA. So these are the choices. This is the method which we are following till now. Now you can see AAB, AAB repeated twice. ABA, ABA repeated twice. BAA, BAA repeated twice. Why they are repeating twice? Because A is repeated twice. We are having 2 A's. That's why we are getting 2 repeated characters. Okay. So if you have seen, we have heard about a formula. Basically, what are the total number of permutations? 3P3, which will be equal to 3 factorial. Now, when we have to get only single strings, that means unique strings, what we have to do? We have to divide this factorial using 2 factorial. Why 2 factorial? Because A is repeated twice. How many repeated characters we have? 2. We are having 2 repeated characters. So what will be your answer? 3. So you can see that we are having 3 unique strings in this: AAB, ABA, and BAA. Understood now? This is the mathematical proof that if you will simply print all the strings, then we will get 3 factorial, 6 ways. Okay, but we are basically printing the arrangement. So you in boxes you have to arrange balls. So in first way you are arranging AAB, and in the third case you are again putting AAB. So exactly same case. So we will not consider this. Okay, so that's why. What is the difference? Why this is happening? Because you can see here, this A decided that it will not sit on the first block. So first block is empty. Basically, first block is empty. Let's AAB. So this A decided that it will not sit on the first block. It will sit on the second block. Easy. Now, when this A came, this A decided that it will sit on the first block. So this will same, na? This will be same. Either this A can be sit on the first block or this A. The answer will be same. So let's see. Basically, this A decided that it will sit here. This A decided that it will sit here. Or vice versa. This A decided that it will sit on the first position. And this A decided that it will sit on the second position. So you can see both the cases are same. Both the cases are same. This is why. This is the only reason that we are getting repeated characters. So how we can prevent this? Basically, when first A decided that it will not sit on the first position. So this is the case. For the second A, this is mandatory that it can sit on the further indexes of the previous A. What I mean, when I'm talking about this A, this A can sit on every index greater than the previous A. So previous A was seated here. So this A can sit from this index to this index. This cannot sit here. Understood? That's why we are taking last occurrence map, because it is storing that at which index the previous A has been put. Okay. So what we can do basically, we have to star. We can put the next A greater than what are the values, what is the range in between. We can put the second A, the index greater than the previous one to the last. So we will find the previous index. So int least index, okay, which is equals to lo.at.ch. So I am getting the index value of previous A. Now where I can place my current A, I can place this from li plus 1 to last index. Okay. And now when I put it myself on the box, I will update the least index value. So what will be the least index value? My current value. So what I will do, lo.at ch equals to li, or not li, I, because we are making a loop now. After that, after coming again, we will make this exactly same, ch equals to li. Okay, this is the very minute change which is required, and rest of the code is easy. Okay, so I hope you guys understood. Let's submit this code. So you understood now basically why we are getting repeated characters, because when this A is deciding, first A is deciding that it will not sit on the first block, that means dash A dash dash. So this A can only be sit from this index to this index. So let's say li is 1. If li is 1, then this A can be placed from li plus 1, that means 2 to last. And then we have to update the value of A, which will be equal to current index. Understood? This is what we are doing. Rest of the code is very. So I hope you guys understood the method second also. I have explained method 1 and method 2 both. So this is all about this video. We will meet in the next video. Till then, bye.